Welcome to Emtron Training Part 23. In this training tutorial, we're going to take a look at working with a mass airflow sensor into a mass airflow calibration type of strategy in our Emtron programming. The mass airflow sensor directly measures the amount of airflow coming into the engine and has unique advantages over calibrating and working in the estimation of airflow in either speed density or throttle mass flow. We're going to cover all of the different aspects to working within the mass airflow type of calibration process, and some tips and tricks in order to calibrate and tune it properly. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with a mass airflow sensor in conjunction with our Emtron ECU. The mass airflow sensor opens up a airflow strategy that we haven't talked about or looked at yet. The mass airflow sensor will directly measure the amount of air mass that's being ingested into our engine. If we're dealing with throttle mass flow or speed density, those will estimate the amount of airflow entering our engine. So it's going to be the difference between either measuring the airflow or estimating the airflow. Now, if we're comparing mass airflow style tuning to speed density tuning that we talked about in our last training tutorial, speed density tuning requires a three-dimensional table to estimate the percentage of cylinder filling that goes into the equation to calculate the estimated amount of air mass. Instead of going through that exercise of trying to estimate the air mass at given load or RPM points, we'll directly measure it, and we'll skip going through this three-dimensional calibration process that is quite time-consuming in order to make an engine run proper. So the mass airflow sensor will save a lot of time and setup in getting an engine up and running and tuning. Now, the advantage of working with a mass airflow sensor is we're directly measuring the airflow, saves on tuning time. So there's some disadvantages I want to talk about before we jump into setting it up and working within a mass airflow mode. The first disadvantage, if we have a leak anywhere between where the mass airflow sensor is mounted and the inlet to the engine. So for example, turbocharged engine, we're running a MAF sensor on the inlet to the turbocharger. That's generally where I recommend to run the MAF sensor. And we're finding that we pop a charge pipe. So between the compressor outlet and the charge pipe going to the throttle body. If we have a leak, if that charge pipe comes off, we're going to be completely misrepresenting the air mass coming into the engine because the compressor is going to be spinning. It's going to be ingesting a certain amount of airflow coming in. The mass airflow is going to register that, but that's not what's actually getting into the engine. It's going to overestimate the amount of air mass. And in this case, we'll run extremely rich. And we'll find the engine's going to run really poor. So we have to make sure there's no leaks in our system before we actually do any tuning, or even after we've tuned the car continuously. We need to check and make sure it's not having any leaks. You can do this with a smoke test if it's naturally aspirated, or a boost leak checker if you're going to have a force induction application. Now, we don't want leaks either way, whether we're going to be estimating airflow or measuring the airflow, but with the MAF sensor, it's going to be directly present and immediately accounted for in terms of being off in our airflow modeling. Speed density, throttle mass flow, if there's a leak, we're not going to know it. It's not going to be represented in that estimation of airflow. So that's going to be the difference between estimating the airflow and measuring the airflow. There's going to be a huge disadvantage to a mass airflow sensor. But either way, we don't want to leak, so we should take care of that before we actually tune, and also periodically check to make sure we're not having a leak as we have operation of our setup in racing conditions. Now, the second disadvantage is going to be a blow-off valve. If you're turbocharged, you have a blow-off valve, and you're atmospherically venting the blow-off valve, meaning you're just letting it blow off to atmosphere, you're going to find that it's going to throw off the measurement of airflow, because as we have that airflow blow off, it's not being ingested into the engine. So for example, we have our mass airflow sensor, turbo engine, MAF sensors mounted onto the charge pipe onto the turbocharger. We have our airflow coming into the engine, into the turbocharger. Everything is going to be working properly, registering properly, as long as we have no leaks. All of a sudden, the blow-off valve opens when we lift throttle. Well, the amount of airflow that we're measuring through the inlet of the compressor is going to be much higher than what's actually getting into the engine. In this situation, a very brief period of time where it actually blows off, the mass airflow sensor will have a huge skewing of reading and measuring the airflow, and therefore it's going to run rich. Same idea as having a leak, but it's just going to be these timed portions of lift throttle where we have the blow-off valve open and it starts to blow off and it creates problems. So if you have a blow-off valve with a mass airflow sensor, you want to recirculate the blow-off valve. That'll get around this problem, but just be aware that it can and will become a problem. Now, the third issue or disadvantage with tuning with a mass airflow sensor. We have the potential to have reversion. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.